Welcome you all to the Spark Research YouTube channel. This is Dr. Vichan, the Assistant Professor in Department of ECE. And in this session, we are going to talk about this particular course, Analog and Digital Communication. And in this particular session, we are going to take some questions which has already been asked in the previous year. And if you remember, we have already discussed 1 year previous discussion. This is another one, right? So here also we will look into the some explanation as well as the question also. These contents may also be the beneficial for the GATE exam preparation. So if you have to, you can do in this channel for your GATE exam preparation also. Okay. So let's take the question. First of all, let me tell you again. This is the external exam will be of total 75 marks and there will be the three parts. So part first will be of MCQ. Here total 20 MCQ will be there. Part B will contain the 5 question. Here you have to solve, and there will be the 5 questions, one question from each of the units. So total 5 question, and each questions will carry the 8 marks. So total 40 marks. And part C is it is of the one question only and either or. So here you have to solve the question number 26 or 27, and this question is of 15 marks, right? So total 20 plus 40 and plus 15 is equal to your 75. So let's take the short questions. So from the unit first, one question you have to solve this one or this one. So first question is your phase discriminator method to generate the SSB. So how will you generate SSB type of the signal? So that is the question, and the either or is the modulation, right? Generation expression for the non-linear modulates with the balanced modulator to generate AM signal, right? So here AM signal you have to generate using the non-linear modulation, and here you have to generate the SSB, right? So two questions. So what is this SSB? SSB is your, this is your actually the signals, that is MT cos omega CT. M is your message signal and cos omega CT is your carrier. And Hilbert transform. Hilbert transform, that is of M of MT, that is your phase shift by 90 degree, and then the sinusoidal of omega CT, right? So how will you generate? So here is the balance modulator, then phase shift, that is the Hilbert transform, and again you can say AF phase shifter will be there, and then another balance modulator, and add both of them. So here finally you will get this AMT cos omega CT, and from here now you will get AC cos omega CT, and here you are getting the Hilbert transform, that is M of HT, this part, and here you will get that part, and finally take it out. So here you will get that, and band pass filter you can get the SSB output in order to avoid the higher modulated wave. Okay, the nonlinear modulator. So what is this nonlinear modulator? Example is your diode. So here message signal is there, and then the carrier signal, and this is the amplitude modulated signal. So this one is your amplitude modulated, right? This one is your amplitude modulated. So here amplitude is varying, that is why this is called the amplitude modulated signal, right? Okay, so MT is here, and then here adder is there, and then nonlinear, here diode is there, nonlinear AD modulator, and then 8, right? And empty, and here this will come, and x2. Actually how will you get? So expression you can write a yt is equal to axt and plus bx square t, right? So put the value like y1. In order to get the y1 you can put the ax1 t plus bx1 t all square, right? And minus, again use the same expression here and put the x2. So from here x1 and x2, put that, and you will get the value, that is x1 t. If you put the values, you will get zt is equal to at this term like this, right? If you will solve and find further, this will contain the higher frequency. So use band pass filter to remove this, and finally you will get the amplitude modulated wave, this one, right? Okay, so in the second question, that is from the second unit, you have to explain the super heterodyne, FM super heterodyne, that is question. And another question either or is that implementation of AM transmitter using the low level and high level modulation, right? So here is the high level modulations. Here if you'll see now, AF high power audio signal is there. So here your power will be very high. Remaining things is almost similar. So RF amplifier we are going to use, and then your carrier wave is same. So that will be used, right? And ST is nothing, your regular amplitude modulated signal, right? So that you are going to transmit. So only the difference is that your amplifier, right? Okay, second question. Now the remaining working principle same. You can also draw this block diagram. So here modulating signal, that is massive signal, modulating amplifier, and class C. Always remember class C type of the amplifier we are going to use, right? In class B, you will be used for turn the power amplifier, right? And finally, you will transmit the masses. Now we'll see, and so we are going to talk. So modulation takes place at a low power level, and signal is then amplified by the class B power amplifier. So modulated by the class C and amplified by the class B. Now we will take the FM broadcast receiver. So generally the same, the super heterodyne receiver structure you can draw. In FM case, only difference is that your image frequency, right? So in AM case, the image frequency is 10 kilohertz. In FM case, image frequency will be 10.7 megahertz, right? Remaining working principle are same. For details, these working principle, you can check the contents, related contents from the unit second, right? We have already discussed. So from third unit, question is that you have to find the probability of error when a signal is absent as well as present on choosing the threshold level of A. Second question is that either or your quantization noise power for PCM is S2 divided by S square divided by 12, and S is the step size, and also describe the PM, PW and PPM, what are all these, right? So here probability of error you can find. So probability of error means whenever you are sending 1, then you are going to receive 0, and you are sending 0, then you are going to receive the 1. So probability of error under that condition, E divided by conditional probability E of H naught, that will be Q of A by rho, and E of H of 1, that is Q of A minus A divided by sigma, right? So after finding it, you can put the values P1 and P0 since binary signal, so both is equiprobable. So you can find the probability of error, and that will be the Q of A by twice of A. And what is this Q function? Q function is nothing, 1 over square root of 2A, integration of minus x to minus infinity e to the power minus x square by 2 dx, right? And quantization, that is PCM. Now here how will you quantize the PCM signals? So here your empty is there. Actually you are trying to write the rectangular function, right? This is the transfer function of the rectangular function, that is sinc function, and then here is the Hilbert transform, and then finally you will get the Q of T, the difference of your M and minus the second one, right? Then further if you will the multiply, you will get the quantization error. So quantization error will be the minus t by 2 to t by 2 q square dt. So you can put this qt here, and then you can solve it. After solving, you will get q square is equal to this. Finally, after you can put the step size, that is del v is equal to twice p by n, and you will get the quantization error. Okay. Also, you can convert this quantization error to signal to noise ratio, and the same things you can convert it into the for a particular L, that is the number of bits, that how many you are using into the dB scale. So this is just a conversion. Already we have discussed for PM, PPM, PWM. We have already discussed in the unit third value. You can check here. PEM amplitude is varying for pulse. For PWM, your width is varying for your pulse, and for PPM, your position is varying, right? Okay, so fourth question regarding the QPSK, and another one is the QM. So QPSK regarding, you can see for this is your QM. So here quadrature, amplitude, modulation. So phase and Q, both will vary, phase and amplitude. Probability of error you can find it. For more details, refer to the unit 4, right? For QPSK, again here four different phase shift will be there. So this is very general equation for any PSK type of the signals, and you can put the I, that is the theta. You can put different theta, that is I is equal to, you will put 0, 1, 2, 3. You will get the different 5, 1, 5, 2. Right. After getting all these, you can draw the signal space diagram also, and then you can assign 0, 0, 0, 1, 1, 0, and like that. Okay. And also these are the corresponding angles for the different phase. So if you will put these values, you will get the all the signal equations for the QPSK. Okay, so probability of error also you can find out here for this QPSK. And 25 number question here related to the capacity, channel capacity for continuous noise channel is the Shannon-Hartley theorem with infinite. And here is the one numerical question, right? So what is this capacity? So first you can solve this numerical question. So you can see here the details. Majorly you have to find the entropy and then find out the information rate, and after that you can use this equation capacity C is equal to B log 1 plus SNR. Remaining values are given, so you can find the value of the SNR, right? After finding it you can find the bandwidth also, right? So information capacity, that is for very like for the derivation you can go to the unit 5 contents we have already discussed here. So this is the final equation, and how will you get? So information is nothing the maximum possible value of the channel capacity, that is maximum information, right, contained by this mutual information I of y of k, right? So that is called the channel capacity theorem, max of information. So how will you find this max of information? So you have to get the here you can see the h of I. First of all, you have to write in terms of the entropy here. This is more important equation, and then this h of yk can be replaced by this, and find the h of k, and then this h of nk, the signal and noise both, and then both you can combinedly you can put, you will get the C, that is channel capacity, right? Okay, so 26, that's all about the all the questions. Now we'll take the long question. So 26 number question. Here this is the drawback of the PSK, and then DPSK, and then FSK, all these, right? So drawbacks you can check it here. The PSK measure phase ambiguity is there, the phase, because you have to keep on changing in the PSK. Then current detection also you should record, otherwise the it is difficult to recover the message. Then phase noise and a bunch of the problems are there, right? You can check it. Then DPSK we have already discussed, that is the differential phase, differential coherent PSK, that is DPSK, right? And here FSK, here we are going to use the two different frequencies. So one frequency, that is F1, another frequency F2, and the signal space diagram you can check it. Okay, then frequency shift keying FSK. Okay, so last question is related to the Hoffman code. So Hoffman coding, how to solve the questions? Again, visit the fifth unit content. So I have taken the same content. Just replace these probability values with the given, right here only three values. So replace all these values and solve it. So what is the step? So step is that the first of all, step one, arrange all these probabilities in the descending order and add the lowest two, right? And after that adding the values, again arrange in the descending order, again add the lowest two, again arrange, right? So keep on adding the lowest two and keep on arranging in the ascending order, and further go through the left to right and write the code from the right to left. You will get the codes. After getting the codes, you can find out the h of s. H of s is the entropy, that will be based on the the probability only, and then you can find the code average code word length, that will depends on this these two, all these things are related to the code words that you got it, right? So that's all. Thank you to join the session. If you have any doubts, please drop me a comment.